All right, guys. So we are going to learn about algebra proofs today. And when we go to do that, or I should say before we start them, we have to learn some properties, okay? So in an algebra proof, if I just show you what one looks like, okay, it looks like this. And they would give you an algebra equation, and then in each step, they would keep simplifying it until they finally solve for x. And what we're gonna do is learn what would we write on these blanks. This is called a 2-column proof, and that happens to be the only proof that we do in this class. Sometimes your book will ask you to do a flow proof, which would look kind of like a flow chart. Even if it asks you to do a flow proof, we are always doing a 2-column proof. Another type of proof that your book will ask you to do is a paragraph proof, where instead of showing it in 2 columns, they would want you to write a paragraph explaining how you solved that, okay? So I would rather you get good at doing one type of proof than learning 3 different types and being, okay at 3 rather than good at 1. So what we are going to have today at times is an equation like this, and we have to solve it. So what would happen is when we solve this, what would you do? You would add 4, right? And you're really adding 4 to both sides, and then you'd get x equals 11. In an algebra proof though, just so you guys know, you don't show the work like I did there. You would just go right directly to x equals 11. And then what the reason would be is addition, and then you have to put prop for property. So whenever you add the same thing to both sides of an equation, that's called addition property. You may want to write down how I abbreviate things so that you remember that when you get to doing them yourself. The next thing that you could see today is something like this. And in this one, we have to subtract from both sides. And if we subtract 5 from both sides, do you guys get that we would get x equals 3? And then you do have to be careful if you abbreviate subtraction, because we also have what's called a substitution property. So don't do SUB for subtraction, because if you did, it would be wrong, because I wouldn't know if you meant subtraction or substitution. So what we do for subtraction is SUBTR, and then that would be prop. Okay, and you do have to put prop, otherwise you lose like a half a point for that on each problem. Okay, so if you go to this one, do you guys know what you would do to solve this? You'd multiply, right? You're basically multiplying by 5 on both sides. So when you multiply by 5 here, these cancel. You multiply by 5 here, and you'd get x equals 20. And again, if you were doing that for the proof, you don't show the work on it. So this would be multiplication, which I just do MULT, and then prop. Okay. Then if I go down here, and I need to do division, because to solve this, I'm gonna divide by 5 on both sides and get x equals 2. And then I do div prop for division property. Okay. All right, now let's look here. So there are 3 types of properties that we use a lot, more so in the sections after our quiz next week. but there is a reflexive property, a symmetric property, and a transitive property that we use a lot in the rest of this chapter. Reflexive property, first of all, if you ever have to abbreviate, is REF prop, okay? And what reflexive property says is that everything is equal to itself, okay? So AB equals AB. This is saying the measure of angle ABC equals the measure of angle ABC. And then A equals A. It could be 5 equals 5. Anything is equal to itself, okay? The second, and one thing I want you to notice too on these, reflexive has one equal sign. Symmetric has 2 equal signs. And transitive has 3 equal signs. So that's one way that you can tell the difference between them if you're ever confused. Okay? So if I look at symmetric, a lot of people call this the switch around property or the flip around property. What it is you take an equation and you flip the 2 sides. It's kind of like how we did a converse earlier in the chapter with sentences. You just take and you flip the left and right side. Same thing if you were talking measures, you would just take those 2 measures and flip them. Okay? Symmetric property. If we had to abbreviate this, we would go SYMM prop. Then if I go down to this one, as I was saying, you have 3 equal signs, okay? For something to be transitive, the ending of the first equation and the beginning of the second equation have to be the same. If they are, you cross those out, and the outside 2 are equal, okay? So again, if I look at this one, the ending of the first one, beginning of the second one are the same. So we cross those out, and the outside 2 are equal. Does that remind you of something that we just learned? Yeah, what was it? Syllogism. We did law of syllogism yesterday, where the ending of the first sentence and beginning of the second were the same, and we cross those out, okay? If I have to abbreviate this, I'm going to just do trans prop. Okay? Now, the one that is hardest to tell typically in a proof, and the one you should guess if you ever have to guess, is substitution property. It's super common in the harder proofs as we get further into the chapter, and it's a common step when kids get confused and get stuck. So I can tell this one does have 3 equal signs, okay? It has 3 equal signs. So does transitive. So you would have to be able to tell the difference between these 2. This one is not transitive because the ending of the first and the beginning of the second are not the same. So what we do then in this one, it's not transitive, so we're going to use substitution, just like you guys learned in algebra class. Do you guys get if x equals 5, that you could pick this x out and put 5 in there? That is what they did. So they just picked this x out and substituted 5 in there and got this. When you abbreviate substitution, you're going to go SUBST prop. Okay. All right, then our last property for this is something you guys are probably pretty familiar with, First of all, if I have to abbreviate distributive prop, I do it like this, okay? And then what distributive property is you're gonna have a number outside of parentheses and you are just gonna multiply like this. So 3 times x is 3x, 3 times y is 3y. So it's clearing out that parenthesis just like you did in algebra, okay? So one of the types of questions that you guys could have is where they're just gonna give you statements and we have to say what property it is, okay? So if I look at this first one here, notice I have 3 equal signs. That means it's either transitive or substitution. Is this transitive?
Yes.
Yes. So then we would just write down trans prop. Don't forget to do the property, because I do take off points if you forget that. Now, if we look at the next one, we're looking at what did they do to this to get here? How did they solve that? What did they do? Division, right? Didn't they divide by 7 on both sides? So then you're just gonna say division prop. Okay? And you always start with the one on the left to see how they got the one on the right. What did they do in C? Subtracted, right? Remember when you abbreviate subtraction, it's SUBTR prop. Okay? Then, do you notice how this one has 2 equal signs? And what do you notice about those? That was symmetric, very good. So for this one, it's just symmetric prop. They flipped them around or switched them around, whichever way you want to think of that. Okay? Now if we look at this one, start on the one on the left. What did they do here to get to this? Multiplied. They multiplied by 3, so we're just going to do MULT prop. Okay. Now this next one, what did they do to the left to get the right? Add. So this is just going to be addition prop. Okay. Then, in this one, what was it called when something equaled itself? Reflexive. Very good. So REF prop. Okay. Now if I look down at H, what did they do from here to here? Distribute. Very good. So DIST prop. Now I, notice this one has 3 equal signs. Is it transitive or substitution? Substitution. And that's because these two are not equal, okay? What they actually did here, you guys, is because AB equals CD, they pulled this CD out and substituted AB in there. That is substitution, SUBST prop. Okay. Now, let's go and we're gonna try our first proof. So, this says day 2, you can ignore that. That's because in my high school class, we learned another thing prior to this and we stopped there, but I skipped that part for us. So, one thing I'll tell you, if you ever get an if-then proof, the if you always put as given, and that's where you start the problem for given. And then you'll also have a prove statement. And that is what you are trying to prove, what you want to end up with. So given is where you start, prove is where you end. Now, if you were doing this in your book, one of the things you're not going to like is that if I was doing this out of my book, even though I only have blanks here, I would have to write out the given, the prove, do my table for statements and reasons, number these and copy those down, and then number these and put my answers, okay? That's every proof that you ever copy out of a textbook. That's what you have to do. When you start one of these proofs, the given is always put on the first blank, and what your reason for that is given. So it's like what you were given to start. Okay? In an algebra proof, it's always your beginning equation. Now I want to mention this just so I don't forget. They tell you what you should get as an answer at the end of the proof. So if you were doing this on your own, you would want to make sure when you get down to the bottom that you get that x is 4, okay? And then the other thing that I see happen with kids is when we did given, we wrote given on the blank. Down here, this was what we wanted to prove. So some kids will write prove on this blank, but prove is not a reason. You do use given, you never write prove as one of your things, okay? All right, so now that we're ready to start, what we're gonna do is look at how did they get from one step to the next. So you're gonna start and just look from step 1 to step 2 and look at what did they do. They not added, distributed, right? So they distributed that 2, and then that would just be DIST prop. Okay. Now, down here, you guys have, I'm gonna give you a new cheat sheet that we won't use very much in this section, but you can use it on your next quiz. We'll use it a little bit back next week on Monday. But I'd like you to copy what's in red up there, like on the top of this, okay? Just so you have that on a cheat sheet for the quiz in case you forget. So just write combine like terms equals simplify. Okay. So most of this cheat sheet here is for the next part of chapter 2, but we will. Like I said, I do want you to copy this down so that you know what it's called whenever we combine like terms, okay? So maybe on the top of that, just write combine like terms equals simplify. And then a reminder, no matter if they ask you to do a flow proof, paragraph proof, or 2-column proof, we are always doing 2-column, okay? So that will happen as we go through too. All right, so let's go back up here. Do you guys get that from step 2 to step 3, they just combine those like terms? When you combine like terms, that is just simplify. Okay. Then, what do you think they did from step 3 to 4? 3 to 4 added, right? So this is addition prop. And then the last step, what did they do from 4 to 5? Divide. So division prop. Okay, and again, if you were doing this one by yourself, make sure that you get the answer that is in the proof up here. If you didn't, then that means you did something wrong. Okay, and you should go back and look at your algebra. All right, so here is one that we're gonna do by ourselves. So to start with, what do I put first? Don't I just write down the given? So I'd go 3 times x minus 2 equals 42, and that is given. Okay, so that's where you start every single proof, is with the given. Now, for step 2, what do you guys think we would do? Distribute, very good. And again, try not to show any work when you do this. You could do it off if you wanted to show some work, off on the side. But it's gonna be 3x minus 6 equals 42. And then like you guys said, it's distributive prop. Okay. Then if I look at step 3, what would I do? Addition, right? I'm gonna add 6, so I get 3x equals 48, and that would be addition, and make sure you put prop. Okay, then if I go, am I ready to be done? What do I do for that final step? Divide, so I'd get x equals 16, and that is division prop. And then again, once you get that x equals 16, go back up and make sure that that is what we were supposed to get. Okay? All right, so now let's look here, okay? And we are given this, okay? So let's copy down what we're given first. So we have 2 times 5 minus 3a minus 4 times a plus 7 equals 92, and that is given. Okay. Now, what would you guys think we would do first? Distribute. And honestly, with this one, you guys, you can distribute both of them at the same time. If you're subtracting something, you want to subtract first and then subtract again if you have 2 different subtractions. But in this case, you can distribute both. So 2 times 5 is 10. 2 times a negative 3a is minus 6a. Negative 4 times a is negative 4a. Negative 4 times 7 is negative 28. And that equals 92. And then like you guys said, that was distributive property. Make sure you do prop at the end. Okay. What does it look like we need to do next? Simplify, right? We have to combine some like terms. I'm gonna put my a's first, you guys. So I'm gonna combine the negative 6a minus 4a. What would that be? Negative 10a, very good. Okay, how about 10 minus 28? What's that? Negative 18, very good. And that equals 92. And what is that called when I just combine like terms? Simplify, very good. All right, now if we look, we're trying to solve for a. What would we do next? Add, right? We'd add 18. So we'd get negative 10a equals 110. Okay. And that would be addition prop. Okay, and then what's the last thing we would do? We would divide, right? So let's go ahead and do that. And 110 divided by -10 is -11, and that is division prop. Now, is that what we wanted to get? Yes. So always check that just to make sure you haven't done anything wrong. Okay? Now, in this one, let's write down our given again. 5x minus 5 equals 3x plus 7 is given. Okay? Now, you guys know when you learned algebra and you had a variable on both sides, your teacher probably said it doesn't matter which side you bring the x to and which side you bring the numbers to, which is still true, but in a proof, if your x is on the left up here, when you finish, your x has to be on the left down here. So the reason I tell you that is it's best to bring your x's to the left in these and bring your numbers to the right, because then your x is automatically going to be over there. So when we go to do this, if I want to bring the 3x over, wouldn't I subtract, right? So I have 5x minus 5 equals 7. I subtracted 3x, okay? So this would be SUBTR prop. What?
Yeah, you've got to subtract the 3.
Oh, I'm sorry. Thank you. Should be 2, right? Thank you. Okay. So now what would I do? I would do addition and I would add that 5, so I'd get 2x equals 12. Whoops. And then that is addition prop. And then the last step would be division. And like how I made my mistake there, if you guys hadn't told me that, I would have gotten a different answer here and hopefully I would have noticed, and then I could have gone back and figured out what I did wrong. But that is division prop. Okay. All right, we have 2 more. So let's look here. And our first thing here is y plus 2 all over 3 equals 3. Okay? Y plus 2 all over 3 equals 3. And that is given. Okay. I want to solve for y. What would you guys think we should do first? What do we want to get rid of? Do we want to get rid of the 2 or the 3? The 3. And right now it's being divided by 3, so what's the opposite of that? Multiplying. So we're going to multiply both sides by 3. Do you guys get if I multiplied this side by 3? Like I said, you're not really supposed to show your work, but I'll just show you this. Don't these 3's cancel? And you would get y plus 2. And then, of course, you'd also have to multiply that by 3. And wouldn't you get 9? That kind of looks like 3 to the 3rd, and it shouldn't. You're just basically multiplying that by 3 also. Okay? So for step 2, what we did there is we multiplied. So it's multiplication property. Okay? Now we need to solve. So what would you do next? We would subtract and we would get y equals 7, which is what we wanted. And make sure you go SUBTR prop. Okay? All right, last one. So if I look at this one, okay, I get 4x plus 6 all over 2 equals 9. That is given. Okay? If you were doing this, what would you do first? Multiply by 2, okay? When I multiply by 2 on the left, the 2's cancel, and you get 4x plus 6. When I multiply 9 by 2, I get 18. And that is multiplication prof. Okay? Now it looks easier. What would you do next? You would subtract, right? So you'd get 4x equals 12, and subtraction is SUBTR prop. Don't just do SUB. Then what we're gonna do is just divide by 4, and we get x equals 3. And that is division prop. And then you can look back up and see, is that what we were supposed to get? And it is, okay? Now, I'm not sure what this is gonna say, but we're gonna do a worksheet. No, this is not right. I'm gonna switch this, but what you're gonna get is a worksheet, and it's not hard. It's just what we have been doing. So I'll hand it out here.
Do I know where it is?
Probably be back in 2 hours before I go.
We had a worksheet, now
I don't think that's necessary, okay? All right, listen up, guys. 1, 2, and 3 on the packet are going to be either symmetric, transitive, or reflexive. So 1, 2, and 3, that's what you would write. And then the rest are just algebra proofs that you will do, okay? I didn't draw in the lines for the statements and reasons, so you might want to do that.